right, guys, welcome to Psych Explained. Before we get started, don't forget to hit that subscribe button. Now, in this video, we're going to talk about an area of the brain called the limbic system. I'll have to say, out of all the videos I've created, this is by far the most requested one, so I'm really excited to dive in. Now, in this video, we're going to talk about what the limbic system is, the parts that make up the limbic system, and its major functions. But let's start with a really important question. Why do we call this the limbic system in the first place? Well, the word limbic stems from the Latin word limbus, which means border or edge. We've talked about this before, but most science words have Greek or Latin roots. And the reason we call it the border is because essentially it's the border between two major areas, right? All these structures in the middle represent the limbic system. We have the bottom of the brain, right? This is a kind of a cross section. The brain stem, which is involved in primitive vital functions for survival like breathing and heartbeat, right? It borders this area. And the top of the brain, which is the cortex, the neocortex, which controls thinking, decision making, and planning, right? Rational thought. So this is the border of our primitive area, our brainstem, and our cortex, which sits right on top. The other thing to think about is why do we call it the system instead of the limbic part or limbic structure? It's because all these structures in the middle, we'll talk about, interact with each other to create some sort of behavioral output, right? So for example, think about this visually. You have all this sensory information, we'll call this sensory input, coming into the brain, okay? What is this? Sights and sounds and smells, right? And your body's got to do something with it. Well, it's kind of like a pinball machine. All these parts of the limbic system talk to each other, right? So if I hear this sound, this structure is going to talk to this structure and say, hey, based on this sound, I think this should happen. And then this structure talks to this structure, and so on and so on. So you create this giant system of interconnected parts that talk to each other that create some sort of, what? Creates some sort of output, right? Which could be behavioral, right? Some sort of action you do based on the sensory information that comes in. It could be an emotional output like laughing or crying, right? Fear, anger, whatever emotion is. It could be a cognitive output, right? Thought you have. But that's a nice way to think about the limbic system. It's this border between our primitive brain and our new cortex brain. And then it's kind of this ping pong action of like bing, 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 bing. Everything talks to each other. And then you have some sort of behavioral, cognitive, or emotional output. All right, so what parts actually make up the limbic system? Now, this is really hard. If you ask 10 scientists what make up the limbic system, you'll have 10 different answers, right? Why is that? Well, one reason is because unlike something like the liver or the heart that you can visualize that has defined borders, a lot of these structures don't really have defined borders, right? It might just be a bunch of neurons packed together in an area, and you're just like, this part does something, but I can't really identify it. So that's one reason. There's not a lot of borders with a lot of these structures, just kind of intertwined here. And the other reason it's hard to identify is because there's just so many structures in the brain that parts interact with. And it's hard to know what deals with just emotions or memories or drives and what deals with something else. So it's really hard to identify all the major structures. So if I leave out structures, which I know I will, I don't want a bunch of hate mail, right? If I leave out the septal area and the mammillary bodies, I don't want hate mail. I know it's part of the limbic system. We're just going to talk about these major structures. All right, so let's start with one of the most dominant major structures in the limbic system. We often talk about this area as the emotional center. We'll label it with our Roman numeral 1. And we call this the amygdala, okay? The amygdala. So what does the amygdala do? Well, for each of these parts, we'll just label kind of the big overarching idea, and we'll get into more specifics later. But the amygdala is really involved in emotional response, right, or emotions. Right, so feelings of anger and fear and even positive emotions like joy, you know the amygdala is probably going to play a big role. All right, what's another major part? Another major part, right next to it, this structure that looks like a seahorse, which is what it's named after, is called the hippo. The hippo what? The hippocampus, right? Nice memory technique. You would never forget a hippo on a campus. Why does it help you? Because this part deals with memory. Memory what? Memory formation, right? Now, a misconception is that the hippocampus stores memories. Well, that's not really true. What the hippocampus does is it more encodes and brings in memories and then kind of connects them to different sensory information. So it's not really a storage tank. It just kind of helps encode and process information. All right, another major part of the limbic system, I think of this as the king of the brain, we'll label it as Roman numeral number 3, is what we call the hypo what? the hypothalamus, right? And just kind of fun information, why would I call it the hypo? Well, hypo means below. So in other words, here's the thalamus, it's below the thalamus. So hypo just means below. That's a nice something to think about. And the hypothalamus does a lot, right? I said this is the king of the brain, but its major function is we're going to write down the word homeostasis, right? And essentially what this means is your body's always trying to find balance. What do you do if you're hungry? You eat. What do you do if you're thirsty? You drink. If you're sleepy, you sleep. If you're cold, you get warm. Your body's always trying to return to that kind of internal balance. And what's in charge of that? Our hypo means below, our hypothalamus. All right, in black, what's another major structure? Number 4, or Roman numeral 4, is what we're going to label, this structure right here, is what we call the thalamus, okay? The thalamus. And the thalamus does a lot. Okay, we're going to label kind of two major functions. One of them, I always like to think of this as the filter of the brain. In other words, think about all the information that's coming into your brain right now, right? Sights and sounds and smells. You can't pay attention to everything all at once. It's sensory overload. So the thalamus essentially acts as a filter. It decides what information you focus on and what you can't ignore, right? I like to think of it like that. Another major function is we're going to write the relay center, okay? The relay center. What do I mean by that? All the information that comes in the brain, right, things from your eyes and your ears, except for smell, we'll talk about that, makes a pit stop at the thalamus, and the thalamus decides where it should go, right? If information's from your eye, it's going to say, go to the visual cortex. If information comes from my skin, it's going to go to the sensory cortex. So it decides, kind of like a pit stop, a relay center, where things should go in the end. So there's number 4. Ooh, I got to write number 4 there. Okay? All right, what's another structure? Another structure, we're labeled number 5 right up here, is what we're going to label as the cingulate gyrus. Okay? Now this structure plays a role in everything. Now we know it connects to the hippocampus, right? There's kind of a little structure called the fornix that connects these together, and because it connects to the hippocampus, you know it deals with memory. By the way, I keep forgetting to write our Roman numerals here. So it deals with memory. It also deals with emotions. It deals with pain perception. It even does things like recognize errors. Like if you're reading something and you recognize a word is misspelled, your cingulate gyrus is like, bing, 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 there's an error, there's something wrong here, we should pay attention to it. So the cingulate gyrus is involved in a lot of different things. All right, what's another structure? This blue right here we'll label Roman numeral number 6. There we go, number 6. There we go, 6 right here. Is a really important structure, okay? Do you ever feel good eating a big cheeseburger, or you got a lot of likes on social media, right? You're like, ooh, this feels really good, right? Or my intro, the euphoria of finding your car that was lost. This structure is what we're going to label as the nucleus accumbens, okay? This is a really cool structure. And we're going to just write down the word pleasure. In other words, anything you do that feels good, that gives you a high, your nucleus accumbens is probably being activated, right? There's probably action potentials, firing at this part of your brain. All right, the last one, we have 3, 4, 5, 6. We'll label as number 7. Let me get my black marker. Is right here, this kind of little bulb right here, 5, 6, 7, deals with smell. What is this little structure right here, right behind the frontal lobe? This is going to be, here's 7, our olfactory what? Our olfactory bulb. You know what our olfactory bulb does? It deals with, well, think about olfaction. It deals with smell, right? That might be a new one. You're like, the limbic system deals with smell? Yes. In fact, historically, the first name for the limbic system wasn't limbic system. It was the rhyencephalon. Woo, big word, which means the nose brain, because when you study rats and rodents, a lot of this area is really interconnected with the olfactory bulb, right? All these projections of the limbic system. So at first they thought this area only deals with smell. Of course, we know a lot differently today. So here are some of the major structures. Now, things we might have left out, the parahippocampal gyrus, which surrounds the hippocampus, the mammillary bodies, these two kind of circle, ball-like structures right underneath the hypothalamus. So there are things we left out. I don't want hate mail, but these are the major structures. Okay, so now that we know the parts, let's dive into some of the functions. We'll start with emotions. Now, we're going to start with a major structure that deals with emotions. You could look at it here. And the part we're going to focus on with this one, we already said it, is the amygdala. Okay? The amygdala. And there's our amygdala right here, that little almond-shaped structure. And what's interesting about the amygdala is that's very tiny. And I think that's really important to know that the size of the structure in the brain doesn't determine the power and influence it has over you, right? I think that's important to know. Just because something's tiny doesn't mean it hasn't had big influence. There are very tiny nuclei in the brain that have a big influence over your life, okay? So let's explain how the amygdala plays a role in emotional response, and of course, how parts of the limbic system interact with each other. So imagine you're walking in your bathroom and you see this nice blue thing, right? We know it's a spider, but how does it actually get to the point where we're like, oh my God, there's a spider there? Well, information, let's think about this together. All right, so information is going to travel to the eye. It's going to convert into action potentials in the retina. Let's think about our eye anatomy. That information is going to travel to where? The thalamus, right? I told you before, it's that relay center, and eventually make its way to the back of the brain, an area called the visual cortex, okay? So there's where we're at, okay? Now the visual cortex is going to connect to where? It's going to connect to and talk to our amygdala. Why? Because this is a threat, right? Now, I know it's not a big threat, but your brain's like, something's off here, I'm in danger, something might happen. So we're going to label the first part of what the amygdala does is it helps detect, okay, detect a threat, okay? Now, this threat can be visual, like seeing a spider. This can be auditory, like hearing a police siren. Okay, or hearing some sort of loud bang. It could be olfactory, right? Smelling smoke. So your brain is always detecting a threat in terms of all of your senses, right? So in this case, we have our visual, okay? Well, what's next? Well, after we detect the threat, a couple things have to happen. One, and most importantly, is you have to actually trigger some sort of response. What does my body do with this threat? So trigger a fear response. Okay, so how does it do that? Well, the amygdala is going to talk to a couple structures. It's going to talk to, most importantly, your what is it? Think about it here. It means below, hypothalamus. Okay, why is that important? We'll have arrows kind of going back and forth. It's because your hypothalamus is what's going to trigger your body to be on alert, okay? And a couple things are going to happen. One, you're going to have the little circle here, your sympathetic nervous system activate. And this is what creates the fight or flight response. What's going to happen? Your breathing will intensify, so your breathing will go up. Your heart rate will go up, okay? Your pupils will dilate, PD, pupils will dilate, right? Your body's getting into that fight or flight mode just in case there's danger. Another thing that's going to happen is your hypothalamus is going to communicate with these two structures here, okay? These two little kind of bulb-like structures hanging called the pituitary gland, okay? Pituitary gland. And I'll put PG here. PG for pituitary gland. We're going to communicate with this as well, which is going to send hormones throughout the body to start this activation of stress hormones. And this is important to know. Your hypothalamus controls your endocrine system. Endocrine system, okay? So instead of activating like heartbeat and you're dilating your pupils, what we're having here is things like cortisol being released, okay? Talking to your adrenal glands, right? Cortisol increases. This is your stress hormone, right, from your adrenal glands, to create that kind of stress response. Norepinephrine and adrenaline in your body is going to fight or flight. So we have communication with the amygdala, the hypothalamus, the pituitary gland. We're also connecting to the hippocampus, right? So we kind of remember this in the future, like, oh my God, there was a spider here, I'm going to remember that in the future. And what's also cool is, I put this structure here. This is your prefrontal cortex. Okay? Why is this structure important here? This is where rational thought takes place. And what's important to know is just because there's a threat, you do have kind of a backup, which is your brain saying, should I be really afraid of this? Right? Question mark, should I be afraid? Well, your amygdala is probably more powerful than your prefrontal cortex and rational thought. So even though it might not be a real threat, your amygdala is going to take over, right? So that's kind of our first major function. We have strong emotional response. All right, so this kind of gets us to our second major function, memory and learning. And if the amygdala is the center of emotions for the limbic system, what would be the center of memory and learning? Well, in this case, we're going to talk about a structure, Roman numeral number 2, called the hippocampus. Never forget a hippo where? On a college campus, right? Memory formation. So just like the spider example, let's think about a real life example. Everybody here has probably been in some sort of car accident or almost a car accident. It can be pretty frightening, right? So you know there's detecting a threat and triggering a fear response is happening as well, right? So a car is coming towards you, right? Let's think about our pathway. We go from our, optic nerve of our eye. We're going to make a synapse in the thalamus, and we'll end in our visual cortex, right? We'll synapse in our visual cortex. And if it's sounds, that would be our auditory cortex in our temporal lobe, right? So think about our different parts, right? So our hippocampus at this moment, after we kind of see the car coming towards us and hit us, is going to start to form a memory of this event. So our first function of the hippocampus in memory learning is memory formation. Memory what? Memory formation. And this isn't all types of memory. We're really talking about our explicit memories. Memories of facts and dates, right? Maybe spatial memory, where you were when this event was happening, right? So maybe our hippocampus is going to communicate through the fornix of our cingulate gyrus, right? Create some sort of connection there. So we're not storing the memory there. We're just starting to encode the sounds, the sights, the smells of this major event. And our second major function is going to be, instead of memory formation, memory consolidation. Consolidation. So what's the difference? Consolidation. Make sure I spell that correctly. What we're saying is we're going from short-term memory, and we want to make sure this memory lasts forever, right? So I want to make sure that I can remember it in the future, so you know it's going to interact with the hippocampus as well. So we want to make sure that the neural connections are really strong, right? So we have kind of two neurons, and the more they communicate, the more you relive this event. We're going to have more neurotransmitters being released. We're going to have more kind of receptor sites open up on the next neuron. And the strengthening of neural connections, do we remember what that's called? It's called long-term potentiation. Okay? So we're starting to, our limbic system is going to help us kind of not just encode, but create this kind of strengthening of this memory so we don't forget it as well, right? And I also have the hypothalamus here too, right? Because, it's going to trigger that fear response. The last major function deals with memory and learning, knowing that I have the amygdala there, is memory emotions, emotional memories. And what I mean by emotional memories is, we're going to start really feeling this memory, right? So when you relive in the future, your heart might beat, right? Your amygdala is going to be activated. Your hippocampus and your amygdala talk to each other. The olfactory bulb might be activated, the smell of gasoline. So the olfactory bulb is going to connect to the amygdala as well. So you have kind of all these structures together that are going to kind of relive this event in somewhat of an emotional way. So that's kind of our second major function. All right, what's our third major function? Motivation and reward. Now, if we have the amygdala for emotions, hippocampus for memory and learning, what's the structure we should think about for for motivation and reward? We're going to start with a structure called the ventral tegmental area. Ventral tegmental area, or we'll abbreviate as the VTA, okay? And essentially it's this structure deep within the midbrain that's packed with neurons. Now, not just any type of neurons, but neurons that we're going to call dopaminergic. Ooh, there's our big word of the day, dopaminergic. Okay? And what this means is all these neurons that are packed together release an excess supply of dopamine. What neurotransmitter? We're talking about dopamine. Okay? And this chemical message, this neurotransmitter, controls everything from pleasure and reward, even motor function, right? Affects Parkinson's disease. And I think the biggest misconception about dopamine is that dopamine is only released when you do something good, like eating French fries or getting a like on social media. But really, it's about that motivation. It's that urge that compels you and urges you to do something, right? So when you're sitting on your couch and you have that urge to pick up your phone. That's really what dopamine is, right? It's the kind of the goal-directed behavior towards something, okay? So just like our other examples of spiders and a car accident, let's think about our social media, right? You're on social media, you're getting all these likes, and it feels good. So what's going to happen? Your VTA, or ventral median area, has axons that are going to project to other parts. Specifically, boop, 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 it's going to synapse with a part called, let's write this in together, your nucleus accumbens. okay? And your nucleus accumbens deals with pleasure. Okay, so when you do something pleasurable, whether it is, eating something sugary, winning money, gambling, could be sex, we'll talk about in a moment, or in this case, getting some likes on social media. Your VTA is going to send out all these dopaminergic action potentials to the nucleus accumbens, and it just feels good. And why is that important? Because you're going to do it again and again and again, and that's, of course, how things feel good. And we'll synapse with the hippocampus as well, because we want to remember to do it again, right? And we want strong emotion, so it's going to synapse with the amygdala, right? So your VTA is going to synapse with all these different structures. And the other idea, knowing I have a heart here, is sex motivation, right? Kind of that taboo topic, right? That drive people have, right, is all controlled by your limbic system as well. The idea is, let's think about the king of the brain or queen of the brain, the hypothalamus. Okay, when sex feels good, your brain's like, let's do it again and again and again, and it's going to release things like, oxytocin. That love hormone, that bonding hormone, testosterone. So this area is involved in not just food and money and likes, but that drive for sexual motivation, right? That would be our hypothalamus. Okay, so there's motivation reward. What is our last function of the limbic system? Homeostasis. All right, do you remember what structure deals with homeostasis? If you're thinking it must be the hypothalamus again, ooh, this structure comes up a lot, you are correct. Okay, hypothalamus. And essentially, what we're saying here is our body's always trying to reach homeostasis, which essentially is this kind of internal balance. Right? If you are hungry, eat. If you're thirsty, drink. If you're sleepy, you got to sleep. And our hypothalamus controls all of this. All right, so let's think about an example. You got pizza in front of you, you're eating. You don't eat too much. You don't eat too little. So how's that going to work? Well, of course, we have our hypothalamus. Right, I'll put H here for this structure right here. And your hypothalamus, we'll kind of draw it together. You could kind of divide into two parts. The top part, we're going to call the lateral hypothalamus. Okay? And this is actually what's going to make us hungry, right? So when this sends out messages, right, down our brainstem to our body, this is going to say eat, right? Eat, 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 right? My blood sugar glucose is low. Let's keep eating. But then after a while, what happens? You feel full. And this is thanks to a part of your hypothalamus called the ventromedial, okay? Medial means towards the middle, right? So ventromedial. And this is going to make us full. Okay, so you kind of have this balancing act for homeostasis of, you eat but not eat too much. Another way to think about it is I have all these structures here that also play a role in making sure that we have homeostasis. So for example, you have all these fat cells. These are going to release leptin, right? This is going to make you full. So that's going to talk to the hypothalamus. You have your pancreas. Do you know what your pancreas releases? If you're thinking insulin, you're doing a good job. This is going to help turn, glucose into fuel. It's going to help glucose enter our cells for fuel. We also have our stomach. What does our stomach release? Well, if you're hungry, it's going to release something called ghrelin. Okay? And this is going to make you hungry. So you kind of have this feedback loop of like, I'm hungry, I'm full, and your hypothalamus is then going to send signals back down your body to communicate as well. So this is a nice way to think of homeostasis. Now I do have another, asterisk there because we have this part called the amygdala. Why is that important? We don't just eat when we're hungry, folks. I mean, there's emotional eating, right? There's an emotional part of homeostasis, which is maybe we just eat because we're bored. Maybe we're eating because we're lonely. And our prefrontal cortex, right, is like, we're not hungry. I don't think it's a good decision to eat. Remember, your amygdala, very strong, is like, I think we should eat, right? So there's definitely kind of like memory, an emotional part to everything that we do, and the limbic system does. All right, guys, thanks for watching. I really hope you liked the video. And guess what? If you're feeling really good right now, it's probably your limbic system that's letting you feel that way. Don't forget to like the video, subscribe. I'll see you next time.